exercise 8.2 of mathematical methods. We are solving now exercise 8.2, that is determine whether the given series converges or diverges. If it converges, find its sum. Following are given sum of the series and you have to tell whether it is converging or diverging. For that purpose, back to these exercise pages, you see here on page number 332, you are given with the geometric series. This geometric series is mostly used in these questions for finding the sum of the series. If the sum of the series in this exercise 8.2 converges, then you need this sum of the geometric series formula to find out the sum. And what is that sum? If you have a geometric series of this kind in which you have some common ratio, if the common ratio is same between the consecutive terms, then you can use this geometric sum formula. And that is a minus a rn over 1 minus r. A is your first term of the geometric series and r is your common ratio. This is for if your common ratio is less than 1. If your common ratio is greater than 1, then you can use here a into r raised to power n minus a over r minus 1. But in most of the questions here in exercise 8.2, you will have the common ratio less than 1. For that purpose, you will use this formula. And in the questions, I will show you that how you are going to find out the common ratio. After finding this sum, you will apply the limit. That is, limit n approaches to infinity on that sum, and you will get the answer for your sum of the series. So also, if you can also use the sum of the series formula as a over 1 minus r. This sum formula is for what? If the series is convergent. If your series converges to s equals a over 1 minus r. But when it converges, if your r is less than 1 here. And it is divergent if r is greater than 1. And if your r is equals to 1, then you cannot say anything about it, that whether it is convergent or whether it is divergent. Another thing that will be used here in this exercise is your comparison test. The basic comparison test, that is on page 339. The basic comparison test, you will just break your function into some similar function of that kind. If your function, the series is given, that series you will name it as an. And you will pick your bn out of that your an. And you will observe the behavior. If the sum of the series bn converges, then your an will also converge. And if your an is divergent, then your bn will also be divergent. This is your basic comparison test that will be used in that exercise. Apart from this, there is another comparison test that is called the limit comparison test. You will just split your function into some other function that is bn, similar to that an. If you divide an with bn and apply the limit n approaches to infinity, and if that limit is not equals to 0, then it can be convergent and it can be divergent, both of them. An and bn, both of them can be convergent and both of them can be divergent. And if you apply the limit n approaches to infinity on it and it becomes equals to 0, then if it becomes equals to 0, then bn is convergent, then this shows that your an is also convergent. And if it is equals to infinity and bn is divergent, then you will say that your an is divergent. So now starting from exercise 8.2, question number 1. The series is given, that is summation 1 to infinity, that is n is equals to 1 to infinity cos pi n. This function is your an. So here in this question number 1, your an equals to cos of pi n. And if you apply your limit n approaches to infinity on it, is equals to limit n approaches to infinity cos of pi n. That will give you 1, and also it can give you minus 1 in your answer. You know that if n is even, if your n is even here, then you will get the answer 1 here. Like for cos 0, cos 2 pi, cos 4 pi. If your n is even, then you will always get here 1 in your answer. And if your n is odd here, then you will get always -1 in your answer. So you can see here also that limit is not unique here, so it is divergent as well. So from this, you can also say directly that limit is not unique, so it is divergent. But we can also say at like limit n approaches to infinity, an is not equals to 0. So as n approaches to infinity, so the given series diverges by using your theorem 8.15 from your book. Now come on question number 2. Series is given from 0 to infinity 1 over 2 plus x raised to power n, and here the limit is given like x mod must be less than 1. Now if you just open this series, this is basically n is from 0 to infinity. Apply here n and see that what kind of series it is. It is, the given series is 1 over, if n is 0 here, this thing whole will become 1. So 1 over 1 will give you 1 here. Now put n is equals to 1 here, you will get 1 over 2 plus x, then 1 over 2 plus x whole square plus up to so on. Now the given series is your geometric series. How you can say that it is geometric series? Just divide your second term with your first term. That will be your common ratio. The common ratio that is normally called as R. The common ratio is R, that can be obtained by dividing your second term with the first term. So this is your 1 over 2 plus x. And how you get that common ratio same? You will divide your second term with the first one. Here you got R is equals to 1 over 1 plus 1 over 2 plus x. Also divide your third term with the second one. Third term with the second one. Divide your third term divided by second term. Also you will get here R is equals to 1 plus 2x. If the common ratio is same, then it shows that this is your geometric series and that will be your common ratio, that is 1 over 2 plus x. So you can find out its sum. So sum is equals to Sn is equals to a into 1 minus r raised to power n divided by 1 minus r. Now what is your first term here? A is your 1 here. So write 1 here. 1 minus r raised to power n. R is 1 over 2 plus x. So this will be 1 plus 1 over 2 plus x raised to power n divided by 1 minus 1 over 2 plus x. Now simplify all these terms. You will get 1 minus 1 over 2 plus x raised to power n divided by, just take the LCM here, 1 minus 1 over 2 plus x will be 2 plus x minus 1 over 2 plus x. So here you will get what? You will get here 1 plus x over 2 plus x here. Now just write it like this will be written as 2 plus x over 1 plus x into 1 minus 1 over 2 plus x raised to power n, like this. You can write it like this. Now your Sn will become, Sn is equals to 2 plus x over 1 plus x into 1 minus 1 over 2 plus x raised to power n here. Apply the limit here. Limit n approaches to infinity, Sn, that will be equals to, you see that 1 over 2 plus x raised to power n, 1 over this thing over infinity will be 1 over infinity, so that will goes to 0. So this whole thing will goes to 0 if you apply the limit on it. So you will get here 2 plus x over 1 plus x. So this is the answer for your sum of series here. Now come on question number 3, that is sum of series 0 to infinity 2 raised to power n over 2 divided by 3 raised to power n. Just open it again by using n is equals to 0 to infinity. You will get here 2 raised to power 0 will be 1. So first term will be your 1 here of the geometric series. The given series is 1 plus. Now put in place of n as 1. 2 raised to power 1 over 2 divided by 3 raised to power 1. So this is basically your under root 2 over 3. So you got here under root 2 over 3 plus. Now put n is equals to 2 here. You will get here 2 over 3 square will be your 9 plus up to so on. Now divide your second term with the first one. Here you will get r is equals to under root 2 over 3. Now divide your third term with the second one. It will be 2 over 9 divided by under root 2 over 3. So this will be 2 over 9 multiplied by 3 over under root 2. You will get here what? You will again get here under root 2 over 3. So it means your common ratio is under root 2 over 3 here. Now you can just find out its sum. That is the sum of series will be a into 1 minus r n over 1 minus r. This will become a is your first term of the series, that will be your 1 into 1 minus r raised to power n means 2 raised to power. This is 2 raised to power 1 by 2. So it will become 2 raised to power n by 2 over 3 raised to power n divided by 1 minus 2 raised to power 1 by 2 over 3 like this. Now it can be solved as this thing will become 1 minus 2 raised to power n by 2 over 3 raised to power n divided by 3 minus under root 2 over 3 like this. You will get here this thing. Now it can be written as, this thing can be written as 3 into 1 minus 2 raised to power n by 2 divided by 3 raised to power n, and here you will get 3 minus under root 2 here. Now you see here we have under root in our denominator. You can rationalize it. You will get here Sn is equals to 3 into 1 minus 2 raised to power n by 2 over 3 raised to power n, and here in your denominator you have 3 minus under root 2. Just rationalize it with 3 plus under root 2, 3 plus under root 2 like this. You will get here Sn is equals to 3 into, here you will get 3 into 3 plus under root 2 divided by this thing. A minus b into a plus b will give you a square minus b square. So this will be your what? This will be your 3 square minus under root 2 whole square. So you will get 9 minus 2. So that will be your 7 here. And what you have here, 1 minus 2 raised to power n by 2 over 3 raised to power n. Now if you apply the limit n approaches to infinity on Sn, this term will goes to 0. So you will be left with what? You will be left with 3 over 7 into 3 plus under root 2. So the given series is convergent and its sum is this value. Now move on to question number 4.